Good morning and welcome back to my channel. Today we are going to discuss on radiographic films. So from the radiographic films itself, from the name itself you understood that these films are related with radiation and these films are used in the radiology department. So where in the radiology department? Radiographic films or the X-ray films. So from that you get the clue that these films are used in the X-ray units for recording the image. You might have seen X-ray films in your lifetime. These X-ray films are simply known as radiographic films. Films are also used in other modalities in the radiology department in CT scan, MRI, mammography, dental radiography. Mammography is related with the radiographic examination of the breast tissue. There also we are using films. So today we are going to discuss only on radiographic films which are used in the X-ray units. So the X-ray film displays the radiographic image. Means if a patient is having a fall or if a patient have undergone an RTA. RTA means road traffic accident, and if the patient is suspecting for any fracture, then we will be immediately rushing the patient to the hospital for taking an X-ray, and the X-ray film will be recording that anatomy of that region of interest in order to determine whether the patient is having any problem, and if with respect to that readings of the X-ray film, the patient will be undergoing treatment. So the X-ray film help us to record the information regarding that object or a tissue through which the X-rays are passing through the patient. So the mode of beam is from the term itself, it is understood that X-rays are used. And it help in diagnosis. Diagnosis means finding out a disease and treatment of the patient's problem. And the energy of the X-ray beam is converted into light by intensifying screen. So how, where these intensifying screens are seen, which is converting these coming X-ray beams into light energy or light beam. So we have to know more about intensifying screen, where this intensifying screen are seen and how it is converting. All those things we will be discussing in the next topic. So the energy of the X-ray beam is converted into light by intensifying screen, and this light is exposing the film to record an image, and the image which is recorded on a radiographic film will be a permanent image. This is a brief structure of an X-ray film. The X-ray film consists of different layers: base layer, adhesive layer, emulsion layer. Other layers are there which will be seen in the next slide. So the emulsion layer is formed of silver halide crystal as well as by gelatin. And the base layer is formed of polyester. It can be of polyester, polythene or a thalapplate, and the most widely accepted is nowadays is polyester. This is the cross section of the X-ray film. These are the different layers of the X-ray film. It is having a supercoat layer, emulsion layer, adhesive layer, base layer. So the X-ray films are having, or the X-ray films are used are of double coated emulsion layer, and the single coated emulsion layers films are used in CT, MRI, mammography, etc. And X-ray films are always double coated emulsion layer films. Again, we will look forward for the introduction to the X-ray films. The first X-rays were recorded on a glass plate, and these were coated with emulsion on one side only. In the previous, it was coated on emulsion on one side, but nowadays the X-ray films are all double coated emulsion layers. And more about the layers we will be discussing on the upcoming slide. Cellulose nitrate base film was used in 1914 for recording X-rays. This film was single emulsion but was quite flammable. In 1924, the safety film made of cellulose triacetate replaced the cellulose nitrate base film. Now polyester film base are used. So nowadays the film having the base layer of polyester. Film base. Again we are going to discuss on different layers of the X-ray films. First we will be discussing on the film base. It is transparent supporting material. Function to provide support for emulsion layer. Polyester is used and its thickness is 0.007 in. So it forms simply the film base is providing a support to the emulsion layer and it is formed of polyester. Ideal features of base material: structural support for fragile emulsion, low light absorption, flexible, thick and strong, dimensional stability, non-flammable. Tinted blue film. Triacetate and polyester are clear and colorless. Blue tint is added to the X-ray film to produce a film that are easier to look at, causes less eye strain. Blue tint can be added to either to the base or to the emulsion. All present X-ray films are blue tint. Emulsion. Emulsion is an important layer of a radiographic film. So we will move on to the emulsion. Emulsion is the heart of the film. Since the X-ray images are recorded on this layer, emulsion layer, the X-ray or the light from the intensifying screen interact with the emulsion and transfer information to the film. So the attenuated X-ray beams when falls on the intensifying screen, these X-ray photons are converted into light photons and these light photons will be interacting with the emulsion layer of the X-ray films and the image is recorded on the emulsion layer of the radiographic film and has two principal components. It can be silver halide as well as gelatin matrix. It consists of a homogeneous mixture of gelatin and silver halide crystal. In typical emulsion, 90 to 99% is AgBr, silver bromide, and about 1 to 10% is AgI. So, silver halide crystals can be silver chloride, silver bromide or silver iodide. So the radiography film deals with 90 to 99% of silver bromide and about 1 to 10% of silver iodide. The silver halide in an emulsion is in the form of small crystal. It will be appearing as crystal lattice. So here you can see an image of silver Ag plus, silver bromide Br minus and Agi. So likewise it will be appearing as a crystal lattice in a radiographic film. An imperfect crystal means perfect crystal has almost no photographic sensitivity. Several types of crystal defects are noted. You can see here a defects noted. Here you can see the crystal defects. A point defect consists of a silver ion that has moved out of its normal position in crystal lattice interstitial ions. You can see here. These are the defects which is seen in the crystal lattice. A dislocation is a line imperfection in the crystal. Causes strain in the wall structure. Iodine ion strains the crystal in this way. Chemical sensitization. Chemical sensitization of a crystal are produced by adding ethylene urine, a sulfur containing component, to the emulsion, which reacts with the silver halide to form silver sulfide. This silver sulfide is usually located on surface of the crystal and is referred as sensitivity speck. It is a sensitivity speck that traps the electron to begin the formation of the latent image centers. So we will be knowing more about sensitivity speck in the upcoming slide. So latent image is simply, you can see a sensitivity site. The sensitivity site is simply known as sensitivity speck. So latent image formation. Latent image is the first invisible image formed on the radiography film. Once we are exposing an X-ray film, an image will be acquired of that particular anatomy, and the invisible image which is formed on the radiography film is known as the latent image. So the relevant radiation interacts with the silver halide crystal. So this radiation, this light photon is interacting with the silver halide crystal, as I discussed in the previous slide. Mainly the interaction which is happening there is the photoelectric interaction. The energy deposited into the film is in the same pattern as the subject that was exposed to radiation, and this invisible image is known as the latent image. A latent image on photographic or radiographic film is an invisible image produced by the exposure of the film to radiation, film to light, that means radiation. So the light means light is coming from the intensifying screen, that we will be discussing on the next topic. By chemical processing, by means of different chemical processing, we are making this latent image is made visible, called manifest image, means an image which can be visible. So this chemical processing, everything is happening in the dark room, and all those things related with processing we will be discussing in the upcoming topics. Formation of the latent image. So how a latent image is formed? Metallic silver is black, so it is this metallic silver that produces black areas on a developed film. Exposure to silver iodobromide grains to light photons emitted by screen X-ray exposure initiates the formation of atomic silver to form a visible pattern. So here you can see an image. The energy deposited from light photons ejects Br electrons. So in this image you can see a light photon is coming. Okay, and it is interacting with bromine. Okay, and when the light photon interacts with bromine, it will eject an electron, and the electron is trapped at the sensitivity spec, where it is trapped and temporarily fixed. As I said before, we are having some sensitivity spec. This electron will be rolling in this crystal, and at last it will be falling on the sensitivity spec. Since the electrons are having negative charge, it will be attracting the interstitial Ag positive ion. Okay, unlike charges attract. So the negative electron will be attracting this positive Ag ion, and the Ag ion and the electron combine to form neutral black Ag. So this in sensitivity spec, it will be formed of Ag, silver, metallic silver will be formed. Silver, the chemical formula is Ag. If greater than 6 to 10 Ag accumulates at spec, it becomes a latent image developer, that is, it is developable. Here you can see another diagram or a diagram showing the formation of latent image. So silver halide crystal you can see. Then there you can see a sensitivity spec. The crystals are seen Ag positive and Br minus. And the light photons is coming and interacting. In the first image you can see a light photon is coming and interacting with a bromine ion, and this will ejects when a light photon interacts with bromine ion, it will be ejecting the electron, and this bromine will become neutral with the ejection of electron, and this electron will be more rotating or revolving in this crystal lattice, and at last it will be falling on this sensitivity spec. You can see in the second image, you can see the electron is seen in the sensitivity spec. So the charge of the electron is negative. So it will be attracting a positive Ag ion towards this sensitivity spec. And there the Ag positive will be interacting with this electron, and it will be become neutral, and it will be formed in the sensitivity spec. Metallic silver. Metallic silver, silver means Ag. The same process is happening with second light photon. Again interacting with next, in the down you can see the light photon interacting with again Br minus. Then the same thing is happening at the end. You can see the sensitivity spec is only formed of Ag. It means it is a latent image. Metallic silver forms the latent image. So steps in latent image formation. Step 1, the light photon interacts with silver halide crystal. The photon kicks out the bromine electron. In the step 2, the kick down electron romps the crystal until it is trapped in the sensitivity spec. In the step 3, the electrons attract the silver ion. The silver ion combined with electron to form metallic silver. This group of metallic silver forms a latent image. Again, in the previous slide, I have discussed that the emulsion layer is formed of silver halide along with gelatin. So, what is the purpose of gelatin? Gelatin is used as a suspending medium and binding agent for the silver halide particles. It is made from bone, hydrolysis of bone. Okay, the material used as gelatin. Why we use gelatin as a binder? The silver halide crystals get finely and evenly dispersed and remain suspended. It will be maintained in a crystal. It is optically transparent. Gelatin does not react chemically with the silver halide. It is porous, so the processing chemicals can penetrate through the silver halide crystal. Since we are processing by some solutions, this latent image should be processed to a visible image. As I said before, the latent image are the invisible image which are made visible by means of processing, and it is of some chemicals. All about processing we will be discussing in the upcoming topics. Next layer is the adhesive layer. It is otherwise known as the substratum layer. It keeps the emulsion layer and base adherent to each other during coating stage in processing. Provides uniform surface over which the emulsion can be coated uniformly. Or it is not having an important role. Its role is only for coating stage. In order to make the base to coat with the emulsion layer, we are using an adhesive layer or the substratum layer. Then the supercoat layer, it provides a protection layer of gelatin, and it reduces the damages from scratches, pressure or contamination during storage, handling as well as at the time of processing. In order to give protection to the emulsion layer, we are using a supercoat layer, and the supercoat layer gives protection to the film. Thank you so much for your patient listening. Hope you have understood about X-ray films and the image formation in the X-ray film. All about manual processing, how this latent image can be made visible. It will be discussed in the upcoming topic. As well as these X-ray films are nowadays a conventional modality since it is advanced to computed radiography as well as digital radiography. Now the X-ray films are digitalized. So more about computed radiography as well as digital radiography we will be discussing in the upcoming topic. Hope you all enjoyed the session. Even if we are knowing more about recent modalities, we have to know something about conventional modalities too, since many of the departments are still following the conventional modalities in many hospitals. So you have to be aware of about conventional modalities too. So you all stay tuned for the next topic. Thank you so much. If you have liked my video, please don't forget to like as well as to subscribe my channel. Thank you so much once again. Thank you so much.